Hey everybody. So hope you had a happy Easter. And now we're going to continue on with what we're doing. We're starting in section 5.3. So for this exam, just a heads up, we're going to be doing 5.1. All right. 5.1 to 5.4 and 6.1 to 6.3. So as far as this goes, we're doing 5.3 and 5.4 and 6.1 this week. And then next week, it's going to be 6.2, 6.3, and then the exam is going to be on Friday. Okay, so there's going to be an exam not this Friday, but an exam 3 is going to be on the 24th. Just giving you a heads up. All right, but anyway, so let's go ahead and do this section real quick. This one's a little shorter than the others have been. So I'm going to start, these are called the double angle formulas. The reason why they're called double angle formulas is that you have your trig function, so I'm just going to say sine, and then here you have 2 theta, where the equation just has theta in it. It's going to be some equation where there's just theta. So what was theta becomes 2 theta. So that's why they're called the double angle formulas. Anyway, let's go ahead and write them out. So the first one is sine of 2a is equal to 2 sine A cosine A. And honestly, this formula right here is Gilbert's favorite formula. Only because this identity, this simplification, identity, equality, it happens a lot in physics. Okay, so it was kind of my go-to. Physics was, for me, was what, back in 2007, and I still remember using that formula all throughout that class. Anyway, so moving on, the next one is sine of 2a, cosine of 2a. Now, cosine has 3 different varieties. This is either cosine squared minus sine squared, or you can write it as 2 cosine squared a minus 1, or you can write it as 1 minus 2 sine squared a. So notice that these two are kind of flip-flop. Flip-flop is probably not the right word to use, but they're similar. They both have the something with a 1 in it, and it's a trig function squared. And we're going to prove those in a bit. And then finally, the last one is tangent of 2a is equal to 2 tan a over 1 minus tangent squared a. Okay? Now, the tangent one you don't really have to memorize, but if you memorize your sine and cosine, you can always recreate it, because remember, tangent is just sine divided by cosine. Anyway, so those are those formulas, and let's go ahead and prove them real quick. And the proofs are all similar, and they're actually not that bad. So to prove the sine one, all we're going to do is we're going to write this as sine of a plus a. And then we're going to use the formula from the last section, the addition and subtraction formulas. So sine is sine, cosine, cosine, sine. So this becomes, sine a, cosine a. The sign stays the same in the middle. Cosine a, sine a. And notice that these two things are identical. So this thing and this thing are the same. So since they're the same thing, it's just 2 times that. And that's all there is. Easiest proof ever. The next one is cosine of 2a. And Hold on, I just realized I had spaghetti earlier and I just realized I had some on my shirt. I'm sad now. Sad times. Alright, so cosine of 2a, we're going to do the same thing. This is just cosine, cosine, sine, sine. So cosine of a plus a. Notice the sign in front of him is a plus. So it's going to be cosine a, cosine a. The sign flips for cosine. And then sine a, sine a. And just like that, there you go. Cosine squared a minus sine squared a. Now the other two formulas for cosine, you get them by changing either the cosine to 1 minus sine squared or the sine to 1 minus cosine squared. And it's up to you. So if you change the cosine to 1 minus sine squared a, because that's what cosine squared is, notice that you get the other formula. And if you decide to change the sine squared, that sine squared is 1 minus cosine squared a with cosine squared a minus and a parentheses around it. Notice that you get the third formula, or the other form. So minus 1 double negative is plus cosine squared a, and so you get 2 cosine squared a minus 1. Yay. All right, so those are your three different formulas for cosine. Now for tangent, it's just again using its formula. Tangent of 2a is just tangent of a plus a, and the formula we had for tangent was tan a plus tan a. You add them up. Oh, no b, they're the same thing. So tan a plus tan a over 1 minus tan a times tan a. And notice that simplifies to the formula. All right, so that's the proof for why those formulas work. All right, so now let's go ahead and do some problems. And again, all we're going to do is use these new formulas both to find values and to come up with new proofs. So the first one, if sine A is 3/5 with A in quadrant 2, find sine of 2A, cosine of 2A, and tangent of 2A. All right, so again, we're in quadrant 2. So that means when you make your triangle, be sure that it reflects the fact that you're in quadrant 2. Quadrant 2 would be like this, where there's your axis, here's your theta. And so we know that sine A equals 3/5. Sine is opposite over hypotenuse. So opposite is 3, this is 5, which means that the missing side should be -4 because we're going to the left. So that's why quadrant 2 is important, because if you had put +4, your values would be off and everything would be incorrect. Anyway, again, if you want to know how did I get that, that was the missing value. And so you just use the Pythagorean theorem. Blank squared plus 3 squared is equal to 5 squared. Blank squared plus 9 equals 25. Then you subtract 25. Or subtract 9. And then you take the square root. So the value that I'm looking for is equal to plus or minus 4. It can only be one of them. And because of the position, I know that it has to be the negative version. So I'm going to get rid of that positive one. It has to be -4. because you're in quadrant 2. All right. So anyway, now let's go ahead and figure stuff out. So I know that sine of A is 3/5. And I know cosine of A, from looking at my triangle, is negative 4/5, adjacent over hypotenuse. And I know that tangent of A is opposite over adjacent, so negative 3/4. And with that, I can figure out all three of these. So the first one is sine of 2A. And remember, that's just going to be 2 sine A cosine A. So sine A is 3/5. Cosine of A is negative 4/5. Now you can use your calculator, but remember that this is really 2 over 1. So it's going to be top times top times top, bottom times bottom times bottom. And so that gives us negative 24/25. So there's sine of 2A. Now I'm going to do cosine. So cosine is just cosine squared A minus sine squared A. And so for that one, and I can use any of the formulas, any of the three formulas I want. I just chose cosine squared minus sine squared. So cosine squared would be, cosine is negative 4/5 minus sine squared is 3/5. And this gives me 16/25 minus 3 squared is 9, 9/25. 16 minus 9 is 7/25. All right, so that's sine A, cosine A. Now to find tangent, it's up to you. You can do sine over cosine, or you can use the formula. Either way, you're going to get the same answer. So let me shrink these up a bit. So the quick way for tangent, in my opinion, is just to do sine over cosine. Negative 24/25 divided by 7/25. The 25's cancel, and you're left with negative 24/7. And that's it. But if you want, you can use the formula. So I'm going to go ahead and do the formula over here. The formula was 2 tangent. For room, I'm going to go ahead and just write it out. 2 tangent over 1 minus tangent squared. So tangent was negative 3/4, negative 3/4. And this is negative 3/2 on top. On the bottom, we have 1 minus 9/16. And then from there, it's just simplifying, and you'll end up with a negative 24/7. But let me crank through it. This is 16/16. 16 minus 9 is 7. So this ends up with 7/16. And then from there, we can kind of whittle it down. Okay, so 16/2 is 8. 8 times 3 is negative 24. Yep. And you end up with a negative 24/7. I kind of did a lot of mental stuff there, but I just wanted to show you that both the formula and doing sine over cosine give you the same solution. All right. So that's the kind of problem you can expect from this section. They give you sine or cosine and then an angle or a number. You create your triangle, and then from there you can find all the other information. So let's do another one like it, except now it's asking for secant and cosecant, and the numbers are a little bit different. So for 2, it says if tangent of theta equals 3, with theta in Q1, find these 3 functions. So again, we're in Q1 now. So my triangle is just the stereotypical triangle. And I know that tangent is equal to 3. So that means that tangent of theta is 3 over 1. That's tangent is opposite over adjacent. So that means that this is going to be the 3, this is going to be the 1. Okay, and so I go ahead and do the Pythagorean theorem. 1 squared plus 3 squared equals the other side squared. I'm going to call it a. And you just do the math. 9 plus 1 is 10. And then you take the square root. And the hypotenuse is always positive. And so we end up with a equals the square root of 10. So I can erase that and just write the square root of 10. Okay. So let's figure stuff out. I know that sine of theta is 1 over square root of 10. This isn't my final answer, so I'm just going to leave it like that. Now, if they were looking for the final answer, I would fix it and put the square root of 10 on top. I would rationalize the fraction. But for now, I'm just going to leave it like that because it'll be easier to work with. Cosine of theta, oh, sorry, that would be a 3. I caught myself this time. Sine is opposite over hypotenuse. And then this one is 1 over square root of 10. So this is adjacent over hypotenuse. And then finally I have tangent of theta. And tangent of theta was what was given to me. It's equal to 3. All right, so the first one they want to find is sine of 2 theta. So sine of 2 theta is equal to 2 sine theta cosine theta. So sine theta is 3 over square root of 10. Cosine theta is 1 over square root of 10. And we can do the math. And we end up getting, remember, top times top times top. This is 2 over 1. Bottom times bottom times bottom. 6 over 10. And 6 over 10 simplifies to just 3/5. Okay. Now notice another one they want us to find is cosecant. Well, cosecant is just the flip version of that. So that's just 5/3. So you just get your answer for sine and you flip it. So I got that answer, I got that answer, and now the last one is secant. But secant is tied to cosine. So cosine of 2 theta is equal to cosine squared minus sine squared. Cosine squared is 1 over square root of 10 squared. Sine squared, 3 over square root of 10 squared. So that gives me 1/10 minus 9/10. Okay, I do the subtraction. That gives me negative 8/10, which is negative 4/5. Let me shrink that so I can have room, or move it to the side a bit. So that is negative 4/5. So that means that secant of 2 theta would be negative 5/4, the flip version of the cosine. There you go. All right. So the next page I have for you to do on your own. It's basically 2 examples like we just did. And now we're going to go to the proofs. All right. So simplify the following without a calculator. And be right back real quick. My cat is all up in my business, and she's not letting me concentrate. Alrighty, he's still up in my business, but kind of pushed him away a bit. So this next one says find and simplify the following without using a calculator. And so when they say without using a calculator, they mean just by using stuff that you've learned in this section. So let's go ahead and do it. No. There we go. So notice that this equation is very similar to 2 sine theta cosine theta. All that's missing is the 2. Okay? So what I'm going to do, give myself some room, is I'm going to artificially add the 2. I'm going to write 2 times a half, or let me think of it this way. 2 over 2, because 2 over 2 is 1, and then I can write down the part that I have. Sine pi over 8, cosine pi over 8. Now the 2 and the sine and cosine, that's the formula. That turns into sine of 2 times pi over 8. And notice the over 2 is still going to be present. So this is sine of 2 times pi over 8 is pi over 4 over 2. And so this becomes, I'll write it as 1/2. But sine of pi over 4 is just square root of 2 over 2. So 1/2 square root of 2 over 2, which is square root of 2 over 4. Again, you don't need to show that many steps. The steps you do have to show, though, are how you created the formula. Meaning that I have to see this step, that you put 2 over 2. You added it in there so the formula could complete. All right, let's look at the next one. Now this next one is just verbatim the tangent formula. This is the formula for tangent of 2 theta, which means that whatever this is going to become the theta that goes right there. So this is the same thing as, but I am missing something for the same reason. If we go up, remember that there's a 2 there. I got that wrong in my notes, and I should have caught it. So notice that there's 2 tangent, whereas this one here just has the tangent. So for the same reason, I have to put a 2 over 2 okay. You know what? I'm just going to write it over here. I'm going to rewrite it. So this is 2 tangent of 112.5 degrees over. Now the other 2 is there, but it's being multiplied by everything on the bottom. I'm not going to distribute it because I have my formula already. The reason is all of this is my formula. So this becomes 1/2 the 2 that's on the outside. So this 2 right here becomes the 1/2 of, and the formula is double 112.5. And so double 112.5, or I'll just go ahead and write it out. 2 times 112.5 degrees. All this stuff's in my way. So 1/2 tangent of 225. And 225 degrees, starting here at 0, 180. 225 ends up being the 45-degree angle in quadrant 3. And tangents plus, minus, plus, minus. This reference angle here is 45 degrees. And so tangent of 45 degrees is just 1. So this is just 1/2 times 1 is 1/2. Okay, so that's what they mean without a calculator. All right, you're just using formulas. And notice the trick that I did. It's the same trick for both of them. If you're missing a constant, in this case I was missing a 2, I artificially add it by putting 2 over 2. And then the part that I need turns into the formula. The part that's left over becomes, in this case, a 1/2. Same thing here. The part that was left over became a 1/2. All right. So the last part is prove 3 of these things. So let's go ahead and do it. A lot of these are just plug and chug, but let's work them out. So the first one is prove that cosine squared is equal to the right side. Okay, so let's go ahead and do it. We're going to start with the more complicated side. So this is 1 plus cosine of 2 theta all over 2. I know that cosine of 2 theta, based on the formula, and it's up to you which one you want to use, but I'm going to use the first one. This is just 1 plus cosine squared theta minus sine squared theta. And no matter what the formula you use, you're going to end up with the similar answer. I just chose the first one. All right. So one thing you'll notice is I can rewrite this. I have 1 minus sine squared theta plus cosine squared theta. So I just changed the order. So I just wrote this over here. And when you move it, be sure to move the negative sign in front of it too. So now this guy becomes cosine squared also. Which is 2 cosine squared. Which again, the 2's cancel, and you're left with just cosine squared. There you go. So that's that one. Let's go ahead and do the next one. Let me shrink this a bit. All right, so this next one is cosecant minus 2 sine theta equals cosine of 2 theta over sine theta. All right, so again, I'm going to start with the more complicated side. And here I have cosine of 2 theta over sine theta. My cat really wants me to pet him. He's just bellying up right in front of my computer. Pet me. All right, and so there's lots of ways you can do this. But notice that the very first thing I want to get is I want to get a cosecant. Okay? Now cosecant is 1 over sine theta. Okay, notice that I already have my sine theta. I just got to have a 1 in front of it. So out of all the formulas to use for cosine, I'm going to choose the 1 minus 2 sine squared theta definition. Because if I do that, that will give me my 1 over sine that I'm looking for. Now remember that cosine has 3 formulas. Cosine squared. I'm sorry, cosine of 2a. So depending on your problem, you have to kind of intuitively guess which one to use. Now if you're using one, you might end up in not getting anything. In that case, switch to a different formula. Part of it is trial and error. But anyway, so we did cosine of 2 theta. We switched it over with this. So this means that I can now have 1 over sine theta minus 2 sine squared theta over sine theta. You don't get to pick and choose what you divide by. You have to divide both of them. But there you go. On the second term, sine cancels out with the squared. I have cosecant theta minus 2 sine theta. And that's it. So this was just like a plug and chug. Happy proof. All right, now the last one is not so happy. So this next one is cosine of 3x equals 4 cosine cubed x minus 3 cosine x. So I try to wing it from scratch on my own. Try to use the double angle formulas, and I was just ending up with a giant mess. So I actually had to look this one up. But now in the future, when I see something like it, I'll try this approach first before I try any others. So the method here is we're going to start with, you think you would start with a more complicated side, but actually we're going to start with this side, cosine of 3x. And I can say that cosine of 3x is the same as cosine of x plus 2x. Now cosine is again cosine, cosine, sine, sine. So this is cosine of x, cosine of 2x. The sign flips, sine of x, sine of 2x. And now I just use my formulas for this cosine of 2x, and I use the formula for the sine of 2x. So I have cosine of x, and this becomes 2 cosine of x minus 1. I'm going to choose to use, so notice my answer has all cosines in it. So when I'm choosing which formula to pick, I'm probably going to pick the one with just cosine in it. All right? Again, it doesn't matter. You might run around in circles for a bit if you pick the wrong one, but you'll eventually get to the same answer. So we have 2 cosine so that's just this guy, minus sine of x. And then the only formula we have for sine of 2x is 2 sine of x cosine of x. All right. Well, I can do a little bit of distributing. I have cosine of x, 2 cosine cubed x minus cosine x. And then here, notice there's sine and sine. So that's minus 2 sine squared x cosine x. Now this sine squared, I'm going to turn into cosine squared minus 1. 1 minus cosine squared. Almost had it backwards. But there's still the 2, and there's still the cosine x next to it. So this is, again, in parentheses. Almost done. I'm going to be bleeding into the next page, but we'll finish it. All right, so now the last thing I got to do is distribute both of these. So I'm going to distribute the -2, and I'm going to distribute the cosine. So 2 cosine cubed x minus cosine x. There, if I distribute the -2 cosine, I get -2 cosine x. A double negative is +2 cosine cubed x. And then I can combine like terms. So we end up with 4 cosine cubed x minus 3 cosine of x. This one's a toughie. If I did put this on a test, it would be bonus. Again, I know I kind of rushed that ending right there. Really, this is just -2 cosine x, 1 minus cosine squared x. And so all I did was I just distributed. And so that ended up being -2 cosine x plus 2 cosine cubed x. Anyway, so that is that. And to put it all together, let's see if I can shrink it so it'll actually fit on page. Yay for computers. Sorry. I know it's kind of boring seeing me just play with this thing. But getting it up here. Here we go. Anyway, so try the next page on your own. Just 3 proofs. See if you can do them. I'll post a video below on Canvas. And we got one more example and we're done with this section. So the last example is if x equals 2 sine theta, write the expression 2 theta minus tangent of 2 theta in terms of just x. So here, this is the same kind of idea where you create your, well, first let's divide the 2 over. X over 2 is sine theta. Sine is opposite over hypotenuse. So here I have my triangle. And sine would be opposite over hypotenuse. And then from there, we can figure out what the missing side is. So I'm going to call it A. But all you got to do is do the Pythagorean theorem. A squared plus x squared equals 2 squared. So equals 4. Subtract. So I have 4 minus x squared. And then finally, I square root both sides. So A equals, and here, I need to look into why the plus and minus isn't there. But I'll look into that and I'll get back to you. I just realized that right now. Like, why doesn't my work have plus or minus in front of it? That's a good question, Gilbert. But for now, we'll just carry through. All right, so I have my triangle. And then from this, we can pretty much get whatever we want. Now, this 2 theta minus tangent of 2 theta is just 2 tangent theta minus 1 minus tangent squared theta. So really all I need to figure out what tangent is. So from this triangle, I know that tangent theta is opposite over hypotenuse, over adjacent. And all I got to do is get that basically get this equality and plug it into here and plug it into here. Now the theta itself, that comes from doing the inverse of this guy. So the first thing we're going to do is we tell ourselves if theta, or if sine theta, you know what, I'm just going to do it over here. So theta is equal to inverse sine of x over 2. So that's what theta is. Now it can be any of them. I could have said inverse sine of this, inverse cosine of this over 2, or inverse tangent of x over that. But usually you go with what they gave you. Since they gave me sine, for theta, I'm going to do inverse sine. If they had given me cosine, I would do inverse cosine. So now I just got to rewrite everything. Instead of 2 theta, I have 2 inverse sine x over 2 minus 2, and then I go ahead and write this ugly over 1 minus squared. And so that is x over the square root of 4 minus x squared. Let me make that look nicer. Okay, so while it looks like we're kind of done because I did everything I needed to, I replaced the sine with that, or the theta with that. I replaced tangent with this nasty thing. I have to go ahead and simplify, and that's where the not fun part is. Nothing I can do for that first term, that stays as it is. But here, this is really 2 over 1. Top times top, bottom times bottom. So it's 2x over all that. Okay, divided by, I'm going to write my division like this. And then this part, I want to get, I'll go ahead and go step by step. I square the top and bottom. So on the top, you get x squared. On the bottom, it just gets rid of the square root. Still not done, though. We got to keep chugging through. It's my cat knocking down my mouse on the floor. So if I rewrite the 1 as the denominator, so if I rewrite this 1, I'm going to temporarily erase it. If I write this as 4 minus x squared over 4 minus x squared, notice that's the same thing as 1. And you get 4 minus x squared minus x squared. So this becomes 2 minus x, or 4 minus 2x squared over 4 minus x squared. Those don't cancel. All right. Almost done. Now, all the stuff we're doing here, this is no longer trig. This is just arithmetic. Knowing how to distribute. So it's division. I change it to multiplication, but I flip the second term. And I can just multiply. So what happens is these guys, this is really raised to the first power, whereas this is raised to the 1/2 power. The square root is the same as raised to the half. So I have something to the 1 over something to the 1/2. You subtract the exponents. It's the same thing. 4 minus x squared to the 1, 4 minus x squared to the 1/2. 1 minus a half is a half. I was going to do this on the do-it-yourself part, and I decided to give you the easier one on the do-it-yourself part. So again, just to show you what I did, this is 1 minus a half. And that takes care of those two. And you're left with just 4 minus 2x squared on the bottom. All right. And yeah, that's it. So final step. Make it look all nice and pretty. Minus 2x square root of 4 minus x squared over 4 minus 2x squared. Excuse me. There you go. All right, so this one, number 9, the do-it-yourself, isn't going to be this tedious with the algebra, but I just wanted to show you a really complicated one. And the complicated part hopefully wasn't the plugging in stuff. The making a triangle and plugging in for each one should be hopefully not too bad. It's the arithmetic that makes it kind of nasty. Anyway, work on the rest, and I'll post a video below on Canvas, and have a good Monday. Y'all got this.